Okay, this section we are going to be talking about probability. So the first two sections were basically trying to help us to figure out how to find outcomes so that we could use that in finding probability. So remember, probability ranges anywhere from 0 to 1. 0 is definitely the outcome will not occur. You know for sure that that will not happen. And then 1 is for sure guaranteed it will happen. So for example, an event that will not occur, I have a dice, or I have one die, and I have all 6 sides with the number 4 on it, and I ask you, what's the probability that you will roll a 3? Well, that's definitely 0. There's no 3s on the dice. You can't get a 3. Likewise, my dice has only the number 4 on it. What's the probability that I'll roll a 4? Well, it's 100%. It's a 1. There's only one number on there, so I'm going to get that number. So your probability ranges anywhere between 0 and 1. You can write those as fractions, you can write them as percents, you can write them as decimals. Anywhere along that spectrum, you can write all your answers in those kind of format. Okay, theoretical probability is the number of outcomes in event A over your total number of outcomes. So that's your theoretical probability. Theoretical and practical don't always turn out to be the same. But in theory, it's the number of outcomes in event A, the total number of outcomes in event A over the total number of outcomes total. So you're over your total. So really easy, you guys have done this before. So kind of like what I just said, the probability of rolling a 5. So on a normal die, there's the numbers 1, 2, 3, 4, 5, and 6 on them. So the probability of rolling a 5 would be, okay, total number of outcomes is 6 because there's 6 different numbers on the die. What do you want? You want a 5. There's one chance of getting, or one possibility outcome of the 5. So it's 1/6. That's your answer. So find the probability of rolling an even number. Well, the total number of outcomes still is 6. There's 6 different numbers on your die. How many of those are even? Well, on the die, these are our numbers on our die, right? 1, 2, 3, 4, 5, 6. How many of those are even? 2, 4, 6. So that's going to be 3 out of 6. So our probability is a half. And like I said earlier, you can write it as a fraction. You could write that as 0.5. You could even say 50%. You can even write it as a percent. So all of those would be okay to write. You could write those all the same way. They mean the same thing. Okay, a community center hosts a talent contest for local musicians on a given evening. 7 musicians are scheduled to perform. The order in which the musicians perform is randomly selected during the show. What is the probability that the musicians perform in alphabetical order by their last name? Assume that no two musicians have the same last name. Okay, first of all, we need to figure out what our total outcomes are. So the total outcome would be how those musicians could perform. There's 7 of them. It would be 7 times 6 times 5 times 4 times 3 times 2 times 1. That's your total outcomes, or 7 times 6 times 5 times 4 times 3 times 1 is the same thing as 7 factorial. That's how many outcomes are possible for just 7 musicians to perform. So that's what goes on the bottom of your fraction, 7 factorial. Okay, what we're looking for is how many ways can they perform in alphabetical order? Well, there's only one way to perform in alphabetical order. That's what we're looking for. So that's 1 out of over the 7 factorial. Okay, so we could go ahead and figure out what that number is. That's probably a really small number, or we could just probably leave it like that. That probability, let's see, 1 divided by 7 factorial. Yeah, that's a really small decimal. Okay, that's pretty small probability there. Okay, the next one, part B, says you are friends with 4 of the musicians. What is the probability that the first 2 performers are your friends? Okay, so first of all, you are friends with 4 of the musicians. What is the probability that the first 2 performers are your friends? Okay, so we got to get 2, so total outcomes, we got to have 2 performers, right? So we've got to have 2 out of, oops, backwards. There's 7 musicians and there's 2 of them. That would give us our total outcome. That's our total outcome. Okay, now you are friends with 4 of the musicians. So what you're looking for is out of the 4 that you're friends with, you want 2 of them to perform. So that's going to be 4 combination 2 over 7 combination 2. Oops. Okay, so 7 combination 2. So that's going to turn out to be 2/7, which is about 0.2857. Or you could say about 28.57% chance that the first 2 performers are your friends. So remember, the bottom of your fraction is always the total outcome. And then the top part of the fraction is what you're looking for. Okay, next one. You have an equally likely chance of choosing an integer from 1 through 20. Find the probability of the given event. A perfect square is chosen. Okay, so let's just say we're putting all these integers in a bowl. So our total outcome, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's your total outcome. There's 20 numbers. Okay, what's the probability a perfect square is chosen? Okay, out of our number set over here, how many of these are perfect squares? 1 is, 4, 9, 16. That's it. So we've got 4 out of 20, which is 1/5, which is 0.2, which could also be 20%. So unless I specifically say what percentage, you could write it anyway, either of those, fraction, decimal, or percent. A factor of 30 is chosen. Okay, well remember our total outcome is 20. That's what goes on the bottom. This is our total outcome. And remember the top is our factors of 30. That's what we want. Okay, so what are all of the factors of 30? Well, if I quickly do all our factor pairs, I've got 1 times 30, 2 times 15, 3 times 10, and 5 times 6. So out of our numbers 1 through 20, the only one that is not in our 1 through 20 list is this 30. So we'll go ahead and drop that out, and we end up with 7 out of 20. So you could say 7 out of 20. You could also say 7 out of 20 in its decimal or its percent. Okay, you pick a card from a standard deck of 52 playing cards. Find the probability of the given event. So find the probability of picking an 8. Okay, well, what's our total outcomes? There's 52 cards. And you want, so this is pick an 8. So how many 8s are there in a deck? There are 4. So 4 out of 52 would turn out to be 113. Okay, picking a red king. Well, once again, our total outcome, there's 52 cards in the deck. And how many red kings? There happen to be 2 of them. King of hearts and king of diamonds. So that would be 1 out of 26 would be your probability. Okay, so this next one says Amanda used a standard deck of 52 cards and selected a card at random. She recorded the suit of the card she picked and then replaced the card. The results are in the table below. So based on our results, what is the experimental probability of selecting a heart? So we've got theoretical versus experimental. So we're just going to kind of look at those two. So based on her results, what's the experimental probability of selecting a heart? Well, right here, are the hearts, and she selected 9. So 9 out of what? What was our total outcome? Well, you're going to have to add up all these slashes. So 5, 10, 15, 20. This is 25 and 30. So 9 out of 30. That's what we're talking about. It was 9 out of 30, which reduces to 3/10 or 0.3 or 30%. Okay, what's the theoretical probability of selecting a heart? Well, the theoretical probability is there's 13 hearts out of the 52 cards, which is 1/4 of the deck, which is 0.25, which is 25%. So her experimental probability is a little high. Probably, she only did 30 trials, so if she did more, she could probably get closer to the theoretical probability. Based on her results, what is the experimental probability of selecting a diamond or a spade? So diamonds, she had 7. So diamonds or spades. So add those two together because remember it's an or, and you'd have 18 out of 30, which is 3/5, which is 60%. So what's the probability of selecting a diamond or a spade? Well, that's half your deck. That's 2 of the 4 suits. So that's 50%. So once again, she's a little high, but if she did more trials, she could probably get her experimental to match closer to the theoretical. Okay, geometric probability, same thing. We still have to have our, instead of total outcomes, I guess it's going to be total area over what we're looking for. It says you throw a dart at the square board. Your dart is equally likely to hit any point inside the board. Are you more likely to get 10 points or 0 points? Okay, so if you look at this scenario, 10 points is the red circle, and 0 points is the white edge stuff. So now remember, you're equally likely. This is not some person who's really good at throwing darts. This is just random. There's no skill involved here. You're just throwing it at the dartboard. So first thing you're going to have to figure out, I guess, is what is your total outcome. So I think it's going to be, since this is geometric, I think it's going to be the total area. So what is the total area of the dartboard? Well, it looks like it is a square. It says it's throwing it at a square board. One of the sides is 18 inches, so I think the total area then is 18 times 18. So we'll just say it's 18 squared. Okay, so then are you more likely to get 10 points or 0 points? Okay, so let's do the 10 points first. So 10 points is the area of the red circle. Well, to find the area of a circle, remember, it's pi r squared. So the radius here on each of those is 3. I don't know if you can tell on the diagram. It might make you think that it's 3 inches total. Each of those, between each concentric circle is 3 inches. So the radius of our red circle is 3. So if I'm going to find the area of the red circle, it's going to be pi r squared. So pi times 3 squared. And then what's our total outcome? It's 18 squared. So we just need to figure out what that is. What is pi times 3 squared divided by 18 squared? Well, if you type that in your calculator, you're going to get 0.087, which is about 8.7%. Okay, now we need to figure out what's the probability of getting 0 points. Okay, so 0 points, it looks like to me is a little bit harder to calculate, but remember the 0 points is the white stuff. So to get the white stuff, I think I would take the square and minus the area of the biggest circle. So the biggest circle would have a radius of 9. So that would turn out to be, so what I'm looking for is the square minus the biggest circle. So the area of the biggest circle is um, pi r squared with a radius of 9, and then that's going to be divided by our total area. So there's our probability right there for 0 points. So that turns out to be 0.215, which is about 21.5%. So probability-wise, you have a better chance, you're more likely to get 0 points than you are 10 points if there's no skill involved and it's completely random. Okay, so remember, that's probability. What you got to remember about probability is you've got to have your total outcomes, right? So you got to know the total outcomes is the bottom part of the fraction, and then the top part of the fraction is just what you're looking for. And that should always range between 0 and 1. So if you get something that's greater than 1, you know you've set something up wrong. Probability is always between 0 and 1.